All right, Mr. Hunt here with surface area and volume of composite shapes. 3 examples. We're going to do surface area and volume of each one. For these, I just highly recommend, there's a lot going on with these. We've seen some before, but we're just going to do a couple more examples and maybe slightly harder with a couple of these. But I encourage you to pause, rewind, look over these as needed. So let's jump in. For the first one, let's start with volume, actually. Volume's usually a little easier. You just add the figures that you need. So, now, what shapes do we have here? We have a prism, and then we have a half cylinder. All right, so volume of the prism, capital B times H. Yes, it's length times width times height as well. The capital B here, let's mark these, 6, 6, 4. The capital B, my base area, let's choose the bottom, is 6 times 6, 36, and the height is 4. Okay, would it work to do 6 times 6 times 4 as well? Yes. So that part's 144. Now what about the cylinder? Well, because it's a half cylinder, yes, we're just going to cut the formula in half. All right, so instead of pi r squared h, we'll do half of that, or you could just say divided by 2. So what's the radius and the height of the cylinder? Let's mark those. Let's go to this actually. So here it would be a radius, right? What's that length? Well, it's going to be half of 6, so it's going to be 3. And then times the height. Okay, again, not up and down. Height is distance between the two bases of my half cylinder. It's going to be 6. All right, 3 squared is 9. Times 6 is 54, and then 54 over 2, we have 54 divided by 2, 27 pi. Oh. Alright, so what's the volume? 144 plus 27 pi units cubed. It didn't, meters, oh, okay. Now, I'd actually didn't do that as a decimal, but if you want to put that in, get a decimal, that's fine. Okay, surface area. We actually have most of the values already, so that's nice. It's just adjusting the formula. Well, we have, now, let's do the prism first. Surface area of the prism. 2b plus p times h. Now, could you, again with these, if you're unsure, there's 5. We won't need the rectangle up here that is covered by the cylinder. Okay, so you could just add up the 5 rectangles. That would work. Or what if we just use the formula? If that's the base, call that my base, well, I don't need the top one. So my formula just becomes the base area, which we already found, 6 times 6, 36, plus the perimeter of the base, 6 times 4, since it's square, 6 times 6, 6 plus 6 plus 6 plus 6, 24, times the height, well, 4. Distance between my two bases, right there, 4. Okay, so put that in, 132. That's the prism. Cylinder, yeah, it's a half cylinder. For a cylinder, I'll walk through it again, but I'll write down the whole formula to start. But you kind of can cut this one in half. Not normally for the shapes, but this one you can. Okay, because you only want for the cylinder. You have half a circle here and half a circle at the other end, so that's one circle. Then for the lateral area around the side, okay, for this, you do only want half of it, so get rid of that too. All right, so it's pi. What's the radius here? 3. Squared, we'd already done that, plus pi 3 times 6, 3 squared 9 pi, plus 6 times 3, 18 pi, so it's 27 pi. So the overall surface area, 132, excuse me, plus 27 pi squared meters. Okay, next again. So in this example, the first thing to notice is what the shape is and what we're going to need. Here's what the shape is. cylinder overall, there's a cone cut out. That sometimes can be hard to see. The dotted lines, remember, are in the inside. We can't see those. If we were actually looking at a figure, we couldn't see that. But we draw the dotted lines to symbolize that. So there's a cone that's been taken out. This is the cone right here. All right, it has been taken out. So it's a cylinder with a cone removed. With cone. I'll just put cylinder with cone. Okay, so let's do volume first. Again, that's a little easier normally. It's just going to be the volume of the cylinder minus the volume of the cone, because we don't want it. So volume of the cylinder, pi r squared, and then we're going to subtract. Okay, let's do this all at once. No, that's fine. Subtract volume of the cone, which is 1/3 pi r squared h. Oh, I need h over here. Sorry. Okay, so first of all, you might notice that they both have pi r squared h, right? So sometimes you might want to say, oh, it's 1 pi r squared h minus 1/3 pi r squared h. That's 2/3 pi r squared h. Those are like terms. Well, actually, the heights are different. So we can't actually combine them. We just got to do it separately. All right, so let's put it in what we know. We actually know pretty much all of these. Volume of the cylinder, the radius is 6.2. The height of the cylinder, 14. All right, let's put it together with this one. Minus 1/3 pi, radius of the cone, still 6.2. Height of the cone, the 14. Okay, so we know all of them. And really from here, it's just plugging it in. I got about 2,817.799. Okay, by the way, good idea to try these, right? Make sure you're getting the same thing I am, and also trying out the values as we go along, trying to work through the problems. Okay, surface area. I'm going to do it all at once. We kind of need to adjust the formulas a little bit. So to start, let's just think about what we have. Okay, I need a couple different things. First, there's this base down here. Now, I don't need this one. That one's been removed. Okay, so I only need one circle, pi r squared. All right, and let's fill it in. The radius is 6.2. There. All right, plus, what else do we need? Well, switch colors here. Let's go. Okay, we'll go with orange. I need the lateral area of the cylinder. Okay, so I'll put that. This one that I'm going to do, lateral area of the cylinder. CYL. So all the way around. Okay, so cylinder is normally 2 pi r squared plus 2 pi r h, but I don't need the bases. I just need the 2 pi r h. Okay, this down here again was the circle right there on the right, and then I need the lateral area for the cylinder. So that's 2 pi, the radius is 6.2, and the height of the cylinder, 28. Okay, finally, I need one more thing. I need, on the inside here, there's this cone, right? I need that lateral area. There's the cone on the inside we need to cover up, that lateral area. So this right here is going to be lateral area of the cone. All right, and well, normally cone is pi r squared plus pi r l. Well, the pi r squared is a circle on the base of the cone we don't need, so it's just pi r l. Where the radius is still 6.2. Now, slant height, we actually don't have. Okay, they give you the height here of 14. All right, so that's 14. And they give you a radius, and there's a right angle. Well, should be. We can assume there's a right angle there. So really what we got is a right triangle with, what is it? This is 14, the height, radius 6.2. Here's the slant height, Pythagorean theorem. Okay, and you're going to get about 15.31. So, put these in. This first one's about 38.44 pi. The second one here is about 347.2 pi. And the third one is about 94.93 pi. Okay, and you add them all up, 480.57 pi. What's our units here? Meters squared for surface area. Or that's about 1509.76. Feel free to pause, look back, and finish up the last example. Okay, so let's look at the volume of number 3 to start. Now, what is this shape? Well, it's really just a cylinder with a chunk cut out. That's all it really is. So what I'm going to do is, it's a cylinder. I'll put part cylinder, we put cylinder. Here's what I got to do. What's a cylinder? It's pi r squared h. Leave a little space there, because I got to add something. Pi r squared h. Well, how much do we want, though? Right? We only want a certain part of it. Well, what fraction do I need? Here's how we figure that out. Look at that angle. They give us this angle here of 120. Okay, that's how much we've removed, essentially, 120 degrees worth of the, if we went kind of all circled, there's an axis here, and we kind of circled all the way around, right, we've got 120 degrees taken out of a total of 360. So how much is left? Well, the cylinder part that we have, there's 240 degrees worth of it. So I'm just going to do a fraction of the entire cylinder. 240 over 360's worth. That fraction, if you're not sure, it's going to reduce to 2/3. So basically we have 2/3 of the cylinder, and I'll fill in the values I know. Radius is given as 4, the height, distance between the bases is 10. Okay. And this will be 320 pi over 3. Okay, feet cubed, cubic feet. You could also write that as 106.667 pi, or it's about 335.1. Okay, let's finish up with the surface area. Okay, so it's 2/3 of a cylinder. So what I'm going to do is I'm going to get let's write in the normal formula, 2 pi r squared plus 2 pi r h. And then at the end we're going to have to add something in, okay? But, so, it's 2/3 though. So I have, right, for the base areas, right there a circle and then a circle on bottom, a part circle. How much of the circles do I have? I have 2 of them, but I have 2/3 worth. So you're just going to do 2/3 of whatever we find here. Okay. Same thing with the lateral area, all the way around here and on the other side. How much do I have? 2/3 of that. Okay, so let me fit in a little 2/3 of that. All right, so then we just plug in. I think we have most of the values. It's going to be 2/3 of 2. By the way, you can multiply 2/3 times 2. It's 4/3. Some people don't like to do that too early, though. Radius of 4. And then 2/3 over here. 2 pi, radius of 4, height of 10. We had all those values. This one's going to be 64 pi over 3. This one's going to be 160 pi over 3. All right, and we can combine those and get 224 pi, adding the numerators, adding the fractions. 224 pi over 3. Now, you think we might be done, but look what's happened. We've created a new surface by doing this. So notice, I've kind of shaded in what we've had. We also have these 2 rectangles that are formed here. So basically, I got to take this, I'm going to add in 2 rectangles. All right, well, let's just do it off to the side. What's the area of each rectangle? Let's see if I get a color here that's going to go in. Well, this is 4, and this is 10. Each rectangle is 4 times 10. Each of the areas is 40, so you have an extra 80 you got to put in here. Okay, and that would be what the area is. It has a decimal about 314.572 squared feet. Thanks for watching. Feel free to pause, go back, and look over these examples.